Hello everyone. I would like to welcome you to the third webinar in the ChromLab software series titled Method Optimization and Automation of Multi-Step Purification. My name is Divya Rao and I am the Tactical Applications Lab Manager at Bio-Rad. ChromLab is a software package that works with the Bio-Rad NGC system to develop, organize, and run chromatography methods as well as collect and analyze resulting data. The ChromLab software is designed to be easy to use and intuitive, and my colleague Benjamin Nickel has previously presented 2 webinars covering the basic features of the ChromLab software and evaluation tools used to analyze run data. The goal of today's webinar is to understand some advanced tools in the software that aid a chromatographer in optimizing purification processes in a systematic, automated, and timely manner. Utilizing the Scouting Wizard for method optimization and 2D tandem purification techniques for automating the optimized method, one can ensure a final product with improved purity, yield, stability, resolution, and reproducibility. For today's presentation, we will be using version 3.1 of the ChromLab software. So let's begin with method optimization using the Scouting Wizard. Now, what is scouting? Biomolecules differ in their charge, hydrophobicity, solubility, reactivity, and intermolecular interactions. And small changes in column chemistry, pH, buffer composition, and other factors can influence the quality of separation in a purification procedure. Now, these factors must be adjusted to produce the most efficient purification strategy. And in ChromLab, we have a scouting tool that enables automated method optimization in a systematic, controlled manner. It can help significantly accelerate method development to attain purification of high yield and purity. The scouting tool allows you to systematically change a single parameter to optimize various conditions. The parameters are pH, flow rate, %B, sample load, buffer choices, and columns. Now, whether you are an experienced chromatographer or just starting out, whether you are commencing on a new project, looking to improve on existing processes, or working on multiple projects where automation and short timelines are key, this is a great solution for you. Scouting helps optimize a protocol that can be used for tandem chromatography. Let's take a look at the hardware requirements for scouting. Scouting for sample requires sample pump and a sample inlet valve to be added to your basic NGC Quest system. When you're scouting for column, you require a column switching valve. pH scouting requires a buffer blending module and a pH module. And no additional modules are required when scouting for ideal flow rate, %B, or duration of each step. Now keep in mind, the modular and flexible design of the NGC makes it very easy to upgrade your system to meet your specific application needs. So let's go ahead and move to the main screen of our ChromLab software. I would like to show you how easy it is to use the Scouting Wizard in ChromLab. As an example, let's choose to find the optimal pH for an ion exchange purification method. So we are going to be scouting for pH. I'm going to go ahead and open a template, the anion exchange. Now you want to change the fluidic scheme so that you select the modules required for scouting for pH, that is the buffer blending module and the pH module. Now the buffer blending module automates optimal buffer preparation over a range of pH and salt concentrations using pre-populated recipes. Now you can click on the select buffer here and select a buffer that has a pH range suitable for your separation. I'm going to click on Tris. And what you see here is that the software also provides the recipe for preparing your buffer of choice. Now once you've made all your changes to your method and your phases, let's go ahead and save this procedure. And now we're ready to use the scouting feature in our ChromLab software. And this scout button is to the left of the Start Run button. So let's click on that. The first window that pops up allows you to choose one scouting parameter from the options below: flow rate, %B, duration, pH, column, and sample. Now notice that the column and the sample parameters are grayed out, and this is because the modules for scouting these parameters have not been selected in the fluidic scheme. The parameters will become available to you once the module is selected in the fluidic scheme. So let's go ahead and choose pH and move on to the next window. And this window allows you to select methods to scout for pH. You can either select one or two or more methods, or if you click on the checkbox here, it allows you to select all the methods within that, all the steps within that method to scout for pH. Let's move on to the next window where you get to choose the number of runs, the starting pH, and the increment pH between each run. So let's go ahead and choose an increment of 0.25, a starting pH of 7, and let's choose to scout for about 8 runs. And what you see here is that I've queued 8 runs starting from pH 7 all the way to 8.75 at an increment of pH 0.25 between each run. We clicked on Finish, we save the method, and we're ready to start 8 runs queued in an automated run, and we're ready to step away from the system. That's how easy it is. So let's take a look at an example of how pH can influence the quality of separation in a purification procedure. So what I've done here is I've opened 10 pH scouting anion exchange runs ranging from pH 7 to 9.25. So what you see here is pH 7 to pH 9.25. Now we are currently viewing the runs in an overlay format after a peak integration has been performed. And for a more detailed understanding of the evaluation tool in the ChromLab software, please refer to my colleague Benjamin Nichols' webinar on this topic. Now what we clearly see here is that small differences in pH does influence peak separation and resolution, and that it would indeed be very valuable to optimize your method to obtain a product of improved yield and purity. Now I'd like to describe to you a purification. This is a tech note from Bio-Rad describing the purification optimization process for the untagged chromogenic Prancer protein. Now the method describes how the ChromLab software scouting feature was utilized for automating column, scouting, and %B optimization of the Prancer purple protein. The Prancer purple has a predicted isoelectric pI of 6.6, making anion exchange an excellent first capture step in the purification workflow. The first step was to scout for columns to identify the optimal anion exchange resin for protein binding. Using the NGC column switching valve and selecting the column variable in the ChromLab software scouting feature, we tested 3 anion exchange columns for Bio-Rad. We tested the MacroPrep, the NuviaQ, and the Unosphere columns for best binding behavior. And comparing results from chromatograms and STS page gel images, we found that the Prancer purple protein bound most efficiently to the Nuvia Q resin. Now with the best column chosen, we next optimized the method's buffer pH, and utilizing the buffer blending valve and the pH scouting option in the ChromLab scout feature, we tested binding of Prancer purple protein to the Nuvia Q over a pH range of 7 to 8.5 in an automated queue for 4 runs. And although the protein bound well to the Nuvia Q at all tested pH, at a higher pH, more contaminants began to bind to the column, and so to minimize contaminants, a buffer pH of 7.5 was chosen. Now, once an optimal pH was established for Prancer protein binding, we optimized the elution step to separate Prancer protein from remaining contaminants by using the %B scouting option of ChromLab software. The shallowest percentage, 0 to 20% B, resulted in optimal enrichment of Prancer protein. So comparing the starting crude material to the final elution fraction on this SDS page, the 3-parameter optimization process was performed with very little hands-on time, and the solution was delivered quickly. Now, the optimization process would have taken weeks if it had been done the manual way. So once the capture process has been optimized, the protein can be loaded onto a polishing column, such as a mixed mode or a size exclusion chromatography column, and this multi-step purification can be performed in an automated and unattended process using our multi-step tandem purification templates in ChromLab. So let's move on to the second part of our webinar, using ChromLab software to perform multi-step tandem chromatography. Now, what is tandem chromatography? Tandem chromatography, also known as two-dimensional or multi-dimensional chromatography, is a 2 or 3-step purification method that allows the user to elute proteins from one column and inject onto a second column without collecting, pooling, and reloading from a fraction collector. The technique saves time and is more automated, therefore more reproducible than with a normal approach. Now, this is particularly useful for tagged proteins such as his-tagged, GST, or the protein A for antibody purification, where the eluate from the affinity column can be loaded directly onto a size exclusion column or a desalting column. For tandem to be successful, the method needs to be optimized by scouting. So here is an outline of a typical tandem chromatography setup. This is a two-step purification of an affinity followed by a size exclusion chromatography. And let me describe this to you. So using a sample inlet plumbed to a sample pump, multiple samples are loaded onto affinity columns, and these columns are immediately washed to remove any unbound protein. And this method is designed to reduce the target protein's exposure to proteases. The target protein is then eluted from the column sequentially in reverse flow using either a linear or a step gradient, and the target protein is then temporarily stored in a sample loop that's plumbed to a second column switching valve. The samples are then loaded onto the second step column, which is either a size exclusion or a desalting column, and the eluate from this column is then collected in fractions from our biofrac. Now let's take a look at a 2D animation of a two-step purification, and this is similar to what I just described, an affinity followed by a size exclusion. So the sample loops here are plumbed to the second column switching valve attached to the inject module, and we start by washing these sample loops in a buffer that's connected to a buffer inlet. Now the affinity columns here, up to 4 of them can be attached in sequence. We then go on to equilibrate the affinity column. Now this is followed by injection of a sample onto the affinity column through our sample pump, and immediately the affinity column is washed to remove any unbound protein and to separate the proteases from the target protein. The next step is to elute the target protein from the affinity column in a reverse manner. It passes through the detector, through the outlet valve, and is stored temporarily in the sample loop. Now going to our second step, using the size exclusion column, we begin by priming the lines with the size exclusion buffer, and then the sample that's stored in the sample loop is then injected onto the size exclusion column. And the eluate from the size exclusion column is then passes through the detector and is collected in our biofraction collector. So this first peak corresponds to the peak coming out of the affinity column, and the corresponding peaks here are purified proteins from the size exclusion column. Now I'd like to go back to our software, the main screen of the software, and I'd like to show you how easy it is to access our Tandem templates. So again, under Techniques, Multi-Column Tandem, and you'll notice that we have different flavors of the 2D techniques. And if you click on each technique, you see that in the overview, it provides the configuration or the setup required for that template. And under the Notes section, you'll see that we have short notes on the method description, column sample, minimum required devices, etc. Now the Tandem templates allow you to choose from a single column to up to 5 columns in sequence. We have a wonderful guide that offers step-by-step instructions on plumbing for Tandem, whether 2D or 3D, two-step or three-step, based on your application and system configuration. Now I'd like to go back to the evaluation window, and let's view an example of a 3-step tandem chromatography chromatogram. This is the purification of a monoclonal antibody using a protein A column, followed by a desalting and followed by a polishing size exclusion column from Bio-Rad, the Enrich 70. Now this absorbance peak that you observe here is from the flow through from the protein A column, and you can see we've collected fractions. What you see here corresponds to the elution of the protein A column. And if you're surprised as to why we don't see a peak, it's because the elution from the protein A is directly loaded onto our desalting column without passing through a detector. We do see an increase in conductivity and a dip in the pH, and this is the elution buffer from the protein A column. Now this peak here corresponds to the desalted partially purified fraction coming out of the desalting column, our P6 column from Bio-Rad. And immediately after that, another dip in the pH and an increase in conductivity. This tells us that the desalting was successful. And the eluate from this desalting column is loaded onto a size exclusion column, and the elution is collected in fractions. And this peak here is our protein of interest, our purified monoclonal antibody that was the yield and the purity was confirmed by SDS gel. So what is our take-home message here? That method optimization and automation of multi-step purification using our ChromLab software allows the exhaustive exploration of purification options to purify an untagged protein without compromising purity. Taking the Prancer protein purification as an example, progress from the 3-capture ion exchange step to the polishing steps, we've achieved a final product with improved purity and yield in an automated, timely, and reproducible manner without the risk of sample loss or operator error. Now, at this time, we've covered the necessary information needed on this topic, and I hope I have convinced you to start using the scouting tool and multi-step tandem purification templates in ChromLab. As you begin to work with your NGC system and scouting in tandem functions in the ChromLab software, you are always welcome to contact us at Bio-Rad Technical Support by phone or email should you need assistance. Thank you for your attention and for viewing this webinar.